Okay, today we're going to be working on 11-7, which is trigonometric ratios. And we have our first question up on the board right now. It says, find the measure of angle J to the nearest degree. So angle J is right here. I've gone ahead and marked it. And as you can see, my triangle, I have two legs and I'm missing a hypotenuse. So a lot of you are probably thinking, well, how do I get this if I only have one angle, which is the right angle, 90s? Well, it's kind of a process, so let's make sure we do it correctly. First thing we need to do is it's asking us for angle J, and though we might not know what angle J is right now, it did tell us our starting point, which is J, right here. Next, once we know where we're going to start, we got to figure what we have. So I can tell you we don't have the hypotenuse. So we know we're going to use sine, cosine, or tangent, but we need to use one that uses what measurements we have. In this case, we have a 9 and a 6. And if you think about it, if we start at J right here, it is going to mean that I have an adjacent leg at 9 because it's right next to J, and an opposite leg at 6 because it's opposite of J. So when you do Sohcahtoa, if you guys remember Sohcahtoa, which one of these, sine, cosine, or tangent, uses the adjacent leg and also the opposite leg? And the correct answer, well, let's check. Opposite, yes. Hypotenuse for sine, no. We don't use the hypotenuse. We don't know what it is. And cosine also uses the hypotenuse. So we're going to use tangent, because tangent uses the opposite and the adjacent, which is the one things we have. So let's go ahead and find the tangent of J. So the tangent of J, we know that it is the opposite, which in this case is 6, divided by the adjacent, which is 9. Now we can divide this and get a decimal and get the tangent of J, but I want to go ahead and keep it this way, especially if we're trying to find the angle. Once we know the tangent of J, we're going to need our calculators out. Okay, so let me show you how to do it. I'm going to bring up my calculator, and what I'm going to do is I'm going to go ahead and divide 6 by 9. And that's going to give me 0.666 bar notation forever. Now, the reason I want to do it on the calculator instead of doing it out on paper right now is because I wanted to go ahead and get the full number. I don't want to round yet, okay? Because the problem has us rounding to the nearest degree. So from here, it's a little tricky, and it's something we've never done before. So let's make sure we really pay attention so we could do it on our calculators. First, we're going to hit the shift key or the second key. And then since we're doing tangent, remember we're doing tangent, we're going to hit tan to the -1 power. Okay, so once we do that, it'll give us the measure of angle J, which is 33.69, and so on and so forth. However, the instructions did tell us to round to the nearest degree. Whoops. To the nearest degree. So 33.69 is going to end up being angle J equals 34 degrees. Not that hard when you really think about how to do it. So it is a little tricky to try to get there, but it's definitely not hard at all. Okay, the next problem we're going to do says find the cosine of y. All right, this should be pretty easy. Remember cosine, if you use Sohcahtoa, cosine is CAH, which means, and actually, we probably should write it this way, CA over H. And cosine actually means adjacent leg divided by the hypotenuse. So adjacent means next to. So if we look over here on y, we know that the adjacent leg is right here. The problem is there's no measurement for the adjacent leg. We know what the opposite leg is, and we know what the hypotenuse is, but there's no adjacent leg. And in order to do cosine, we need to know what the adjacent leg is. So good news is we know how to find the leg. All we have to do is use the Pythagorean Theorem. Remember that the Pythagorean Theorem is a squared plus b squared equals c squared. So a and b are both legs. C is obviously the hypotenuse. So my first leg is 16 squared. My second leg, I have no idea what it is, so I'm going to leave it as b squared. And my hypotenuse is 34, as you can see by my triangle over there. And we're going to square that. Now, you wouldn't know this without using a calculator while doing it by paper, but I already have it written down. So I can tell you that 16 squared is 256. Plus b squared, once again, don't know what it is. And 34 squared is 1,156. So now we just need to solve for b, and then we have our missing leg. So we're going to go ahead and subtract 256 from this side to get b squared by itself, and then we're going to take away the squared. So we got b squared equals 900. Oh, all right. So now, in order to get b by itself, to take away a square, we know what gets rid of squares, and that's square roots. So we square root the b squared, and we're left with b. And all we got to do is square root 900, because what we do to one side, we have to do to the other. So the square root of 900 is 30. All right, so I have my missing leg now. It is 30. So now I can actually get down to doing my problem. Before, all this work was just to find the missing leg. Now I have the leg. Now let's get down to cosine. So once again, cosine, sorry, I erased it. Cosine is Sohcahtoa, and that's the middle one, so it's ka. And so it's c, which is cosine, equals a, which is adjacent, over h, which is the hypotenuse. So your adjacent angle, or your adjacent line, I'm sorry, is 30. And you're going to divide that by 34, which is your hypotenuse. Now, if you work that out on the calculator, the cosine of y equals, if you work that out on the calculator, you should get somewhere about the cosine of y, whoops, let's fix that really quick. The cosine of y is about, usually says to round to the nearest 10,000, so we'll go 0.8824. And that's not bad, so that's the cosine of y. It's really easy if you have all the measurements, but sometimes you don't, so you have to figure them out. But even Pythagorean Theorem is something we remember, and it's still pretty easy to us, so good luck with that.